Okay, one last topic to review from Algebra 2. Um, the title up here is Completing the Square, and there are some elements of this that are really similar to completing the square. Don't panic about that. If you're like, oh, I remember this and it was hard and all of that. This really just feels like mathematical trickery to me. It's going to be kind of like recognizing patterns and moving things around in ways that you maybe wouldn't have normally thought of. Um, and the reason we're doing this is because of these inverse trig derivatives, okay? So these are just up here to remind you what they are. That the derivative of the arcsine function, 1 over the square root of 1 minus x squared, derivative of the arctan function, 1 over 1 plus x squared, and then there's the inverse secant function derivative here. This one doesn't come up a whole lot, by the way, okay? It's really going to be these two that you see, and even those don't come up a ton. So the thing with these is when you are given this, when you're given this function, and I say find the antiderivative, if you don't recognize, like, oh, I recognize that, and that's the arctangent derivative, you might mistake it for one of those other types of antiderivatives that we've been working on. You might think it's a U substitution, or you might think it's a long division problem. Like, these look really similar. That's why these are all grouped together this way, okay? And just to complicate things a little more, sometimes it's not just an x. So I actually want to go in the derivative direction with this first. I'm going to do another example. I'm going to flip this paper over. You can write this down if you want to. And I want to show you what would happen here if this was an arctan, but it wasn't just an x. Okay. So let's say that I asked you to find the derivative. Okay. Of arctan of 3x plus 1. Okay. Well, I hope your brain is screaming chain rule at you. I hope you're looking at this and saying, well, I would have to do the derivative of this 3x plus 1 first, and that derivative is just a 3. Okay. And then I would say, all right, and it's 1 over 1 plus, normally this would be x squared, but now this thing that's underlined is my x. So it would be like 3x plus 1 squared. We did a whole worksheet on these first semester. You guys were really good at them, okay? And so that would be the derivative, and you would look at that and you would feel really good about that, okay? Now remember, our focus right now is doing antiderivatives. And so if you saw this, you could probably get away with doing a U substitution. You could do a U substitution with the 3x plus 1. That would cancel out your 3 here, and all of a sudden you would have something that looks an awful lot like that arctan derivative, okay? But the complication comes in if someone comes along and cleans this up. What if someone comes along and makes this all pretty so we don't recognize the pieces of this anymore? So for example, maybe they would take this 3 and put it up on top here. Okay. And on the bottom, what if they foiled this? Well, that's going to give you a 9x squared plus, let's see, it's going to be a 3x and a 3x, so plus a 6x. And then I would have a plus 1 with another plus 1. Whoops, I wrote that in the wrong order. Wrote it the way I said it, sorry. You have that 1 plus sitting in front there. And then they said, well, that's really gross. I don't want a 1 and a 1 here. So maybe they wrote it like this. 3 over 9x squared plus 6x plus 2. And they said, hey, that's my derivative. And that's great. That is your derivative. And that's a way more like simplified version than what we had up here, right? That's all cleaned up. But if I now give you this and ask you to find an antiderivative of this thing, you've lost your ability to do U substitution because you can't see what's inside those parentheses anymore. Okay. And so we have to get a little bit creative. We have to look at this and somehow figure out, like, hey, could I turn this back into this, which then lets me turn it back into this? It's going to require some factoring. The completing the square piece is like, how can you make this thing appear? It's not going to feel like the normal completing the square I think that you're used to. It's more about saying like, well, I know I need a 1 plus sitting out here, and then I know I can factor this thing. Okay, those are kind of the steps we're going to be taking here. So when I'm starting one of these problems, when I look at this guy, I would probably first think about u substitution, but I don't see anything that's inside something else, so it's not u substitution. But that'd be where my brain would go first. Then I would probably think long division, okay? But this isn't really long division because it's something smaller on top and larger on the bottom, so it's not really a long division thing. And so then I'm thinking, well, could it be one of these in disguise? I'm not seeing a square root. I'm not seeing an absolute value, but could it be this thing? Okay. And so to make it sort of look like this thing, I know I need this 1 plus sitting in front. So right now I'm just going to mess with this bottom piece a little bit. Okay. So I'm going to have x squared plus 4x plus 5. Oops, sorry, it's a minus. Fix that. And I'm going to say, well, I really want this to have this 1 plus sitting in front. Okay. Well, that 1 plus has to come from somewhere, and it's going to come out of this 5, right? So now that 5 is no longer a 5. Now it's going to be a 4. X squared minus 4x plus 4. Okay. And this still works because my 1 is here, my 4 is here, and that would make my 5. But I just kind of pulled the 1 out front. And then I would want to look at this thing in parentheses and ask myself, can I factor this? And specifically, can I factor it as a perfect square? Because I really need it to be something squared in order for this to work. Okay. Well, this is, if I factor, I need to multiply to positive 4 and add to negative 4. So I can do that with a negative 2 and a negative 2. So it's really x minus 2 squared. Okay, well, that kind of puts a different spin on things, right? That if I know that this is equivalent to this, then I can recognize this thing as this is an arctan function when I do an antiderivative. It's an arctan, but it's not an arctan of x, it's an arctan of x minus 2. Okay. And the top is still a 1, and that's okay because my derivative of x minus 2 would be a 1. So even if I did chain rule, remember that example I did over here? It had a 3 sitting on the top, and that 3 came from the fact that there was a 3 in here that when I did the derivative with the chain rule, that's where it came from. But in this example, I don't have that because my derivative here would just be a 1, and that's why I have a 1 sitting on top. So sometimes, like I'm looking down here, okay, sometimes if I have a number sitting up here, really it's a result of the chain rule, and that's okay. But this would be my antiderivative. Oh, I should throw a plus CN here because it's just a general antiderivative. But that's what I mean when I say completing the square is just, can you manipulate this thing to look like what you want it to look like? Okay. Let's try this next one. And by the way, I think I might have thrown you off the scent here. If you have a number sitting up here, it can be a result of the chain rule. It can also be a result of like this arctan could have just had a number sitting in front of it, right? So when we do our antiderivative here, I'm saying that ahead of time because I think that's what's going to happen down here. But let's run through our steps again. So first, I would think u substitution. This one is a tricky one because this one you could do, or you could think that you could do it with u substitution. There is something inside a square root function. However, I want you to think about this ahead of time for a minute. And if you try it and it doesn't work, that's okay. But I want you to start to recognize why it's not going to work. When I do my u substitution and I do my whole like dx substitution, I'm going to be putting in like a 1 over something with an x in it, which, like the derivative of this thing, I'll have 1 over the derivative of this thing, which is meant to cancel with some other x in the problem. There is no other x in this problem. So if you don't believe me, pause the video right now and try doing it with u substitution. It's not going to work. Okay. And I recognize why you think it's u substitution, but it's not. All right. And that is the hardest part of these problems. What it is this guy in disguise. Okay. It's something over a square root of 1 minus something squared. Okay. But that something squared is really messed up down here. And so I have to try to figure out where that's coming from. So again, I am just going to take this piece, the negative x squared minus 2x, and I'm going to play with it for a minute. I want it to have a 1 hanging out in front. And that's harder this time. Before I had a 5 that I could pull a 1 from. Okay. I don't have any constants here. All I have are x's. So here's what I'm going to do. I'm going to make up a 1. I'm going to pretend that there's a 1 there. I'm going to put a 1 there. I'm going to say it's 1 minus x squared minus 2x. And this is going to feel more like real completing the square to you. But I can't just do this, right? I can't just suddenly put a 1 here unless I make that 1 cancel out later on down the road, right? I'm allowed to put this 1 here, this magical 1, if I then subtract a 1 down the road, right? Because now the 1 and the negative 1 would cancel each other back out and I'd be back to this, okay? So I put those magical 1s in there. Now, I want it to be 1 minus something squared. So what I really need to do here is pull this negative sign out so that I can put all of this in parentheses. So I'm going to say this is 1 minus x squared, but I'm going to make this positive now because I'm putting a negative out in front of the whole parenthesis, right? I'm like factoring out a negative. So plus 2x plus 1, okay? And ask yourself at every step in the process here, would this still be equivalent to this? All right. If I gave you this and I said simplify it, would it turn back into this thing? It absolutely would, because you would say, oh, well, 1 minus 1, those are going to cancel. And then this negative sign applies to both of these, and they're both negative. Okay. These parentheses, is that a perfect square? This is what I mean when I say completing the square. We created something here that is a perfect square. Okay. This thing, x squared plus 2x plus 1, factors into x plus 1 squared. Okay. If you don't believe me, I'm looking for things that multiply to 1 and add to 2, and that would be 1 and 1, right? So 1 minus x plus 1 squared. Okay, so really what I'm looking at up here, and I didn't take the time to rewrite it up top. I maybe should have, but now what I have. Oh, and then the other thing I'm going to do is I can tell that this 5 is not a chain rule 5. This 5 did not come from here anywhere. So I'm going to put the 5 out in front of my integral, which I'm allowed to do anytime I feel like it. And now I'm going to say this is the square root of 1 minus x plus 1 squared dx. And now I recognize that as this, okay? Except my x is not an x. It's an x plus 1, and it's got a 5 hanging out in front of it. So I'm going to say for my answer that this is really 5 times arc sine of x plus 1 plus c. And if at any point you're not sure, take this thing and do the derivative, do chain rule, okay? It's going to be 5 times something, right? My derivative of this is 1, so it's still just going to be a 5 times whatever. And then it would be 1 over the square root of 1 minus x plus 1 squared, and then backtrack. And if someone came along and simplified this thing, it would turn back into this thing we started with. So these take a little bit of creativity, okay? If you have thought about U substitution or even tried U substitution and it's not working, if you have thought about long division and it doesn't seem to fit, this is another possibility, okay? And I will tell you that these are going to be the two you see most often. I don't know if I've ever seen an antiderivative of one of these guys, just because it would be super obvious with this square root sitting in front. Like, whatever your x was, you would be able to tell because you would have a square root sitting here. So you're not going to see these hardly at all. It's going to be these two, okay? And the big difference between them, of course, is the square root versus the non-square root. So if it's got a square root in it, there's a good chance it's an arc sine. If it doesn't have a square root in it, there's a good chance it's an arctan, okay? So we're going to give those a try. We're going to mix those in with the other things we've been doing. We're going to practice with them. Not all of these problems work exactly the same way. Like I said, they take a little bit of creativity sometimes. But good luck, and we will power through them.